So Module 5 is on growth models, and you guys saw growth models in Secondary 1, where you saw and compared linear to exponential growth. So we're going to split Module 5 into two videos. So the first video will talk about linear growth, and the second video will talk about exponential growth. As you look at growth models, the main reason we look at it is because it helps us understand how things are growing in the world. Population in an area, which determines what kind of businesses are going to be built, what kind of roads are going to be needed, how many schools are going to be needed. And so growth models are very useful in our everyday world. So when we look at any type of growth model, there's two types of formulas. There's a recursive equation or a recursive formula and an explicit formula. So when we look at recursive, a recursive equation is useful if we know the previous value. So in order to find the next value in a sequence, we have to know the previous value. And so this is nice when we have just the current information and we're looking for the next one. But it's not very useful if we're looking for a number or a value, let's say in 20 years, because you would have to know what happens on 1 through 19 in order to get to 20. So it's a little bit more work. An explicit equation is nice because it allows you to find the value at any time. So it's more useful because it's always going to be easy to find if you have an equation. So we can calculate the population at any time directly without needing to know the previous one. We just have an equation, we plug in what we have, and it spits out our answer for us. So as we look at linear growth, which is you guys first learn about linear growth in 8th grade. And so as we go through, we talked about it again in Secondary 1, and we compared it to exponential growth and how it looked different. Remember, in linear growth, the idea is that it's adding or subtracting the same number each time. And again, there's two formulas. There's a recursive formula, and there is an explicit formula. And when we're looking at the recursive formula, these two pieces never change. They always stay p sub n and p sub n minus 1. And all that means is the number that we're looking for and the number that we had previously. And d, our d value is our growth rate. Like, what are we adding or subtracting each time? Growth rate. All right. In an explicit formula, it looks a little bit different. P sub n is always going to be p sub n, and n is always going to be n. But p sub 0 is going to be our initial amount. So what happens at time 0? And our d value is still our growth rate. And we write that as an equation. So this is kind of like mx plus b, y equals mx plus b when you guys did linear functions. So when we look at example 1, it talks about considering a population, sorry about that, that has an initial population of 70. So an initial population of 70 means that's our p sub 0, okay, our starting amount. And it says it grows according to a recursive formula. So this is our recursive formula, which means this value right here at the end is our growth rate. So when we go to write the information down, we have p sub 0 is 70, and our growth rate is 85. So when I go to find p sub 1, the idea is in order to find p sub 1, I would need to know p sub 0, and then I would add 85 to it. And we know p sub 0 is 70, so we're going to go 70 plus 85, and we're going to get p sub 1 is 155. And then they're like, all right, in order to find p sub 2, if we're using a recursive formula, that means I need to know p sub 1, and then I'm going to add 85 to it. So p sub 1 we know is 155. And then if we add 85 to it, we're going to get, looks like what, 240? And so forth. So we could keep going forever and ever and ever. But what they're saying is, well, it would be easier if you just wrote an explicit formula right from the beginning and you would get the same answer. So p sub n would equal P sub 0, which we know, plus our D amount, which is 85, times N. And so then if I was going P sub 100, all I'm doing is I'm going to take that 100 and I'm going to put it in the spot of N. So I'm going to go 70 plus 85. And the N here is now going to be 100. So I'm going to put 100 in. And then I'm just going to do the work. So this is 70 plus 8,500. And so I would get P sub 100 is 8,570. And I can just use my explicit formula a lot easier instead of me having to go P1, P2, all the way to P100. Because in order to find P sub 100 in a recursive, I would have to know what happens at P sub 99, which means I would have to go through all of that process. Where if I use an explicit, I can just plug in my 100 and get my answer out. So example 2 talks about a population of beetles that are growing according to a linear growth model. So again, it tells us that it's a linear growth model. So it's either going to tell us explicitly, or it's going to say something about it increasing by 5 every week, or 10 every month, or 20 every year, whatever it happens to be. It's going to have something that's going to help you know that it's linear. Again, the initial population is 4, so this is P sub 0. And it says the population after 10 weeks, so this is N, is 114. So this is P sub N. And what we want to do is write an explicit formula. And what we don't have is the growth rate. And so as we look at our formula, remember it is P sub N is equal to P sub 0 plus D times N. So what we're going to do is plug in those values. So we know that P sub N is 114. We know that P sub 0 is 4. And we know that we're looking for D. And we know that N is 10. And so what we're going to do is just solve this equation like we normally would. So we're going to subtract 4 from both sides, which gives us 110. And then 10 times D is 10D. And then we're going to solve this for D, so we're going to divide both sides by 10, and we're going to get D is equal to 11, which is great. That tells us our D, or what our growth rate is. But the problem here is that it's asking for the explicit formula, so we're not quite done yet. We want to plug these values in for D and P sub 0 and get an explicit formula. So we're going to write P sub N, because it always stays P sub N, P sub 0, which was 4, our D, which is 11, and N stays N. So this would be what they're looking for as our explicit equation or explicit formula. So now when I look at example 2 and it says, well, how many weeks is it going to take? So we're solving for N. This is the part we don't know when the population reaches 235. So this is our P sub N. And we're going to plug it into that formula up above and just solve. So P sub N is 235. And that's going to equal 4 plus 11N. And we're looking for how many weeks it's going to take to have 235 beetles. So we're going to subtract 4. So this is 231. And then we're going to divide by 11. And so what happens there is it's going to give us, that's going to give us 2 with 1 left over. So 21 weeks. So it's going to take 21 weeks for us to get 235 beetles. So that's all for video 1.